Hello students, welcome back to all. In this video, I would like to explain about the formation of pcl5, right? So, phosphorus pentachloride, how the pcl5 will form and what is the hybridization will takes place in case of phosphorus pentachloride. Let me discuss all the topics clearly. So, get ready students. So, pcl5 in pcl5 there exists sp3d hybridization because phosphorus is a central atom. It is making five bonds with the chlorine atoms, right? So this is the pcl5 structure. So this is pcl5. So phosphorus is a central atom. It is making 5 bonds with the 5 covalent sigma bonds, single covalent bonds with the 5 chlorine atoms. So here let me discuss about the phosphorus. So generally we know phosphorus atomic number is 15, right? So its configuration is neon 3s2, 3p3 and 3d0. So here this is the ground state electronic configuration of phosphorus. In the ground state configuration there are no electrons in the d orbital actually. But in the first excited state its configuration is changes to neon 3s1, 3p3 and 3d1. What happening is here? One electron is excited from s orbital to d orbital. So here in 3s1 orbital there is one electron. In 3p3 orbital there is 3 electrons, 3px1, 3py1, 3pz1. In 3d orbital there is one electron. So by intermixing these three, so there exists sp3d hybridization. One s orbital, 3 p orbitals, 1 d orbital. So by intermixing these 5 orbitals, so here the phosphorus atom will exhibit sp3d hybridization, right? So total number of 5 new orbitals will form. And the 5 new orbitals, each orbital having one electron in each case, because here there are total number of 5 electrons, 1 2 3 4 5 electrons. So here also there exist 5 new orbitals, sp3d hybrid orbitals, all the orbitals having equal shape and energy and all orbitals having single electron in each case. So let us see how the pcl5 will form, how the phosphorus will forming bonds with the chlorine atoms. Let me draw. So this is phosphorus atom. So here there are 5 new sp3d hybrid orbitals were there. So this is first one, second one, third one, fourth one and fifth one. So these 5 are 5 sp3d hybrid orbitals, phosphorus containing. In each orbital there is one electron in each case. So 2, 3, 4, 5. So now let us explain about the chlorine atom. So generally we know the chlorine atom is atomic number 17 and its configuration is neon 3s2, 3p5, right? So here in this case 2 electrons in s orbital, 5 electrons in 3p5 orbitals, right? So here the chlorine atom requires only one electron to get the complete configuration, octet configuration, right? So here in chlorine atom the 3pz orbital is overlapping with the phosphorus atom. So here the phosphorus atom is overlapping with the chlorine atom's 3pz orbital. So this like this. So this is 3pz orbital. So this is second one, third one, fourth one, fifth one. So like this, there exists a sigma bond between the phosphorus atom and chlorine atom. So there exist 5 sigma bonds between the phosphorus and chlorine atom. So like this, pcl5 will form phosphorus pentachloride. So here 5 sigma bonds will form between the phosphorus and chlorine atom. It is very nice. So here let me explain one more point. Here the shape of the pcl5 is trigonal bipyramidal. So let me draw the structure clearly. So this is the pcl5 structure. It is trigonal bipyramidal. In pcl5, let me explain the bond angles clearly. So generally this is the structure of pcl5. So in pcl5 there are two types of bond angles are there. So here there are two planes are there. So this is the one plane, which means there are total 5 pcl5 bonds are there. So these 3 bonds are making an angle of 120 degree with each other. So these bonds are termed as equatorial bonds, right? So let me write down. So listen carefully. So here these 3 bonds, see, first PCl bond, second, third. These 3 PCl bonds out of 5, these 3 PCl bonds are making 120 degree angle between each other. So that is why these bonds are termed as equatorial bonds. Is it okay? And there are 2 more pcl5 bonds are there. These 2 pcl5 bonds are presenting above the plane and below the plane. These 2 are making an angle of 90 degree. See here the bond angle is 90. In between the bond angle is 120 degree. So these 2 are called axial bonds. Is it clear? So generally the structure is trigonal bipyramidal. This is the structure of pcl5. But here 2 types of bond angles are there. Here 3 phosphorus chlorine bonds are making 120 degree angle. So these are called equatorial bonds, and the remaining 2 are presenting above and below the plane. These 3 are called axial bonds. So let me explain one more point. So this is the phosphorus atom, chlorine, 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 chlorine. So generally here these 3 chlorine atoms are presenting in the one plane. So these are making an angle of 120 degree. These are called equatorial bonds, right? So remaining 2 are making an angle of 90 degree. These 2. These are called axial bonds. Is it okay? These axial bonds are presenting above and below the plane. So now here we have to remember one more point. The axial bonds, these two axial bonds are suffering more repulsive interaction from the equatorial bond pairs. Because, so therefore the axial bonds have been found to be slightly longer and hence slightly weaker than equatorial bonds. So because of these equatorial bonds, these axial bonds are facing some repulsive force. So that is why the pcl5 molecule is more reactive. So this is one of the important point you have to remember. And here the bond angle is two types, 120 degree and 90 degree. The shape of the molecule is trigonal, bipyramidal. Hybridization is sp3d. So total number of 5 sigma bonds will form between the phosphorus and chlorine. So sp3d hybrid orbital of the phosphorus atom and 3pz orbital of the chlorine atom. This is what the formation of pcl5. So this is today's class, and in the next video I would like to explain about the structure of SF6. Okay, thank you all.